So good morning, everyone. This is Jayashri, and I work in the digital twin space as a digital twin engineer. And today's presentation is going to be about the smart shift, digital twins driving industrial intelligence. So I work for a British climate technology company, and their focus is to decarbonize the world's most carbon-intensive industries. And as you can see in the slide, that's how the decarbonization system is going to look like. It converts methane into two high-quality products, graphene and hydrogen. And my work involves developing a digital twin for this particular decarbonization device. So now about my project, what is the value of the digital twin? Why is it so vital for a company like Levidian? Firstly, data-driven decision making. So currently, there's like no understanding of the run data within our organization. So developing that early culture of insights is the first most crucial benefit that we're looking for. Secondly, because we are building 21st century loop, and I am using one of the most powerful cloud platform called Azure for my development, it gives us a competitive edge. Next, efficiency and cost reduction. I think that's one of the mutually inclusive benefits that we're looking for when it comes to developing a digital twin. Next comes the scalability feature, because the loop system, that is the decarbonization system, is going to be deployed across different locations, UAE, UK, North America. So I need to develop that scalable architecture for the digital twin to adapt to different locations. And finally, it's born digital. So I am building every element that's involved within the digital twin from the ground up. So I'm not using any in-house softwares or readily available digital twin softwares for the development. And when I'm going to be showing you the architecture, I will tell you what are the core elements that I'm using within my project. So now about my project, what am I developing? So again, this is not a very comprehensive architecture, but it gives the core element of what are the main elements I'm using within my project. Firstly, ontology model, and I'm sure majority of you would be using this within your organization, especially if you're dealing with digital twins. So in terms of like an industrial smart manufacturing perspective, it is a model that captures the technical properties, data properties, the functional characteristics of an entire asset or a system or a business process in a single piece of dashboard. So this is according to my definition, and it forms the core framework for organizing, defining, and connecting all your data. The second step is to develop the direct connection, that is from the physical system to the virtual system. I think that's one of the main definitions of a digital twin. So how am I doing that? It's by a direct link from the core control system to my digital twin environment. So for that, I am using this self-developed function app within the Azure ecosystem. So what is a function app? It's a serverless solution that helps us to manage less infrastructure, save less cost, and create as many as resources as you want to without the need of deploying any intermediate servers. So that's the basic functionality of this function app. And we do have like a lot of SDKs within that environment. And all of this, which will enable maintenance, prediction, and feedback. So this is a digital twin instance. Again, I'm exactly using the same environment for my digital twin. And this is an example of an arm, but here we can replace it with my system here. So towards the left, we can see the different elements, and you're able to see just 5 or 6 different elements here. But in my example, like in my digital twin use case, I have embedded around like 50 to 60 different parameters, considering temperature, pressure, voltage, power consumption. All of these values are getting updated in real time every second. So if there are field service engineers within our organization, they'll be able to look at the digital twin and immediately reflect or just change the parameters if they want to. And towards the right, you can see the state of the asset. As in, I have embedded 3 different states. That is, if the asset is in running mode, if it's in idle mode, or if it's in error mode. And if it's in error mode, it's going to be, again, similarly embedded with a different color. If it's going to be in idle, it's a different color. And in the all property section, again, as I mentioned, along with its metadata, you can see all the values getting updated in real time every second. So what are the benefits that I've achieved through this development? So firstly, real-time asset monitoring. We're able to look at all the 50 to 100 different parameters that getting updated in real time and immediately reflect on it. Next comes the alert configuration. So I have used different APIs to configure alerts through two different channels, one through SMS, another alert is through Outlook. So if there's one channel that's not working, we get an alert to another channel. And what does that alert have? It has the error code, as in what is the code that is associated with the defect, along with its description of the error, along with its entire body of the message. So all of this is being reflected on my digital twin, which will lead to improved field service efficiency and enhanced operation visibility. Next comes the reporting and monitoring dashboards. So I have embedded an output connector to my digital twin called Power BI. I'm sure majority of you know. So what does this do is from my digital twin, all the live data is being fed into my dynamic Power BI dashboard. And in the time series format, we'll be able to visualize the outliers or if there's any correlation or if there's any thresholds within the data in real time. So that contributes to the reporting and monitoring dashboards. Finally, high quality data and reliable analytics. So as I mentioned, there wasn't any, there was a very fussy and congested data in the beginning, but now I have dedicated containers for my loop systems, and that doesn't need any normalization, cleaning, or transformation techniques. It's a very high quality data with reliable analytics. The next phase was the machine learning phase. So I have given focus on two different elements here, which is the predictive maintenance to be able to identify if there's any faults within the system or to predict what is the fault within the specific asset, or in this specific time, this particular part might fail. So that contributes to predictive maintenance. Then comes the yield prediction, being able to predict what the graphene quantity would be, because that's one of the main output of my loop systems. And anomaly detection to look into the unusual patterns within the data, to look into the positive and the negative trends of the data, and also to know what are the most important feature and the least important feature, which will all contribute to overall equipment effectiveness and efficiency optimization. So this is going to be my future vision and next steps, starting off with the component twin, which is there in the majority. I think that's the first maturity level of digital twin. Asset twin is the one that I have developed for now, a digital twin for an entire loop system. The next vision would be federated digital twin, that is having a single presentation layer and multiple different digital twins running in the background. And the clients would be able to see each and every, like they'll be able to visualize what digital twin is for the multiple loops here, which will all lead to enhanced predictive modeling, automated decision making, and self-optimized products. So yeah, thank you all for your attention and patience throughout the session. Let's keep the conversation going. Thank you.
In your delivery of these case studies, or the building of the tech stack, in the case of Levidian, what was a surprising obstacle that you came across, or an unexpected obstacle that you came across in trying to do it?
Okay, so one of the main challenges is to connect the physical system to my digital twin environment, because I am not supposed to be using any mediator or any broker in between. So I made use of like the existing function and libraries to do that connection. And also because there's like no proper data, as I mentioned, for digital twin, digital twin relies heavily on data. So there's like no proper data that was collected. So I had to do it from scratch. So I collected data from scratch from my digital twin, and that's how I resolved that challenge.
And Jayashri, from your development of your stack, anything that you've come across that was an unexpected win or a benefit or a delight?
I think we initially did not have an idea to utilize AI into incorporate AI into digital twin, but then we eventually made use of object detection, because we have two outputs, and then making use of object detection, custom vision technologies into digital twin. We had a sudden benefit through that. And we also incorporated responsible AI dashboard so that our users can actually look into that, and also look into the carbon footprint, as in what is the carbon footprint of the entire organization or for the entire software. All of that was an additional benefit for the digital twin developed.
Jayashri, on your side, you're doing some brilliant stuff. You spoke about the benefit of bringing AI in and object detection and so on. How did you initiate the project? How did you start to sell the benefits of the work that you were going to do in advance of getting the work done within Levidian?
step was building a prototype, like a mini prototype, and then show them that these are the benefits and this is how you can monitor the data within the asset and how the data is going to be live streamed. So I was like a mini prototype using like a simulated data, not like an actual data. So using that prototype demonstrated the benefits, and the clients and the stakeholders, they understood what the benefits are. And then I moved on to developing an actual like model. So that is how I moved from like a mini prototype to an actual model.